Let's learn A-level chemistry topic reactions of benzene. But before we actually starts with the reaction of benzene, let's understand the structure and bonding of benzene. The molecular formula of benzene is C6H6. That is, there are 6 carbon atoms and 6 hydrogen atoms. So the empirical formula turns out to be CH. Now let's understand its structure. We can see here the hexagonal ring structure. Now this hexagonal ring structure presents 6 carbon atoms. You can see that each carbon atom is bonded to 2 other carbon atoms, and there is 1 hydrogen atom bonded to each carbon atom. So each 6 carbon atoms are bonded to 1 hydrogen atom each. Also we can see that there are 3 double bonds. Now the main part of this double bond is that it doesn't stay localized between these 2 carbon atoms. It actually keeps on shifting, moving to the next carbon atoms, which we are showing here with arrows. So when we want to present this double bond shifted to the next carbon atom, let's see how can we present it. The carbon double bonds are shifted to the next carbon atoms in the benzene ring. So it's presented it this way. So if we want to show an overall structure of benzene, we can show a hexagonal ring structure with a circle inside it. Now this circle represents the pi bonding system of benzene, which is delocalized. Now when a benzene undergoes a reaction, this delocalized system of benzene remains intact. So what kind of reaction does a benzene undergo? It actually undergoes an electrophilic reaction, and that also a substitution reaction. Substitution reaction means the hydrogen atom which are bonded to each of this carbon atom are substituted by an electrophile. Now what's an electrophile? Electrophile can be presented in general as E positive. So you can call electrophile as a positively charged species which is also an electron pair acceptor. Electrophile reacts with the compounds which has a good electron density. So you can also say that electrophile species reacts with compounds like benzene or alkene, or any such other compounds with a good electron density. Now when an electrophile reacts with a benzene, as we have already discussed, it's actually an electrophilic substitution reaction. So what is electrophile going to do is, it's going to remove 1 hydrogen atom from the benzene, and then it gets substituted by the electrophile. So we can present a benzene ring with an electrophile as shown here. So electrophile will take a place of any 1 hydrogen atom from the 6 hydrogen atoms bonded to each carbon atom. So the hydrogen atom is removed out. It can be presented as H+. So you can say that actually the hydrogen ion gets substituted. Now let's learn the mechanism of the electrophilic substitution reaction which benzene undergoes. So when a benzene reacts with an electrophile, out of the 3 double bonds of benzene, one of it forms the bond with electrophile. So we can present an intermediate of this reaction as here. So as we have already discussed it here, out of the 3 double bonds, one of the double bond forms a bond with electrophile. Now with this carbon atom, hydrogen is still bonded here. So there are only 2 double bonds left inside the benzene ring, which can be presented as a half of the ring with a positive charge in between. So you can say that there is an intermediate formed with a positive charge. So in the final product, the hydrogen bond, the bond of carbon and hydrogen gets broken, and that moves inside to form the pi bonding system of benzene intact again. So now the final product is formed with an electrophile on the benzene and hydrogen atom being removed out. So here is the electrophile and hydrogen ion is removed out. As you can see that the bond of this hydrogen and carbon gets broken and it shifts inside the benzene ring, making the 3 double bonds intact again. All the electrophilic substitution reactions of benzene have the same mechanism, where the intermediate will have a positive charge, but in the exam, when we draw such an intermediate, when we are supposed to show the mechanism of the electrophilic substitution reaction, we need to be very careful showing this half ring with a positive charge covering more than half of the benzene ring. So you can see that here I have drawn a ring which is from this carbon atom to the other part of the benzene ring. So it covers more than half the benzene. Now let's see the types of reaction a benzene undergoes. The first one is halogenation. In halogenation reaction, we add any halogen to the benzene ring. Second one is nitration. In nitration, we add a nitro group to the benzene, forming nitrobenzene. The third one is acylation or alkylation. Together we called it as a Friedel-Crafts reaction. In this reaction, we add an extra carbon to the benzene. So you can say that we add a carbon or a carbon chain to the benzene. In acylation, we are actually adding an acyl group to the benzene. The fourth one is sulfonation, where we add a sulfo group to the benzene, forming benzene sulfonic acid. Let's start with the first reaction of benzene, halogenation. Suppose if we want to add chlorine halogen to the benzene, we need the reagent chlorine. But along with the main reagent, we need a catalyst also, say aluminium chloride. If we want to add bromine reagent to the benzene, we have to take the catalyst as aluminium bromide, that is AlBr3. In place of aluminium chloride, we can also take some other catalyst like iron chloride, zinc chloride. They are the halogen carriers and they have vacant orbitals in it. These halogen carriers are typical Lewis acids. So when an chlorine reacts with the benzene, it forms chlorobenzene, replacing out one of the hydrogen atom from the benzene. So it is presented it as a chlorine on the benzene and hydrogen moves out. Now the byproduct which will be formed here will be HCl. Here the main role of the catalyst, that is aluminium chloride, is to form the electrophile. Now let's understand the reaction which creates an electrophile. So when aluminium chloride reacts with chlorine, it forms the electrophile, that is Cl positive and AlCl4 minus. This electrophile reacts with the benzene to form the chlorobenzene, and we have already learned the mechanism through which all the benzene undergoes the electrophilic substitution reaction. Now when hydrogen ion is replaced out, this hydrogen ion again reacts with the AlCl4 minus to form the byproduct HCl, and then it regenerates the catalyst aluminium chloride. The next reaction is nitration. That is, we are adding nitro group to the benzene. Now the main reagent for this reaction is concentrated nitric acid. The catalyst which we need is concentrated sulfuric acid. So in this reaction we'll be adding nitro group to the benzene, so our product is nitrobenzene. So NO2 group is bonded to one of the carbon atom of benzene, replacing out the hydrogen ion. So in this case our byproduct will be water. Again, the main part is played by the catalyst to generate the electrophile. In our reaction, in this case, the electrophile is obviously NO2+. So when nitric acid reacts with concentrated sulfuric acid, it obviously produces the electrophile nitronium ion. NO2+ is also called nitronium ion. The remaining part of the reaction is as shown here. Now this electrophile NO2+, that is nitronium ion, reacts with the benzene, producing nitrobenzene. Our next reaction is alkylation. As the name presents, we are adding an alkyl group to the benzene. So suppose if we want to add a methyl group, that is CH3, then our reagent is chloromethane. And the catalyst we need here is aluminium chloride. So when this reacts along with the catalyst aluminium chloride, we get methyl benzene. Methyl benzene means we are adding a methyl group CH3 to the benzene. So a CH3 group is added. Again, the role of catalyst here is to make an electrophile CH3+. So our byproduct here will be HCl. Let's see the intermediate reaction which a catalyst undergoes to produce the electrophile. It is similar to the one which we have learnt in halogenation. So this produces the electrophile CH3 plus and AlCl4 minus. This electrophile CH3 plus reacts with the benzene to produce methyl benzene. The next reaction is acylation. This reaction adds an acyl group to the benzene. So suppose if we want to add an ethanol group. So we need the reagent ethanol chloride. So what's an ethanol chloride? CH3COCl. Again we will here need the same catalyst, aluminium chloride. As similar to the earlier reaction, an ethanol group is added to the benzene. So a COCH3 group is added. Now here we can see that the CO bond, the CO part of the ethanol chloride bonds with the benzene. That is, the C bonded to oxygen reacts with the benzene. Again here the byproduct is HCl. And aluminium chloride produces the electrophile by reacting with ethanol chloride. The electrophile produced here is CH3CO plus. Now this plus charge is on carbon atom and the other product is AlCl4 minus. The next reaction is sulfonation. Sulfonation of benzene, the main reagent is concentrated sulfuric acid. H2SO4. Now in this reaction, when sulfuric acid reacts with the benzene, it's actually the sulfur which is making bond with carbon. So the group added to benzene will be SO2OH and the byproduct will be water. Here a bit of warming is needed in this reaction. Even in the reaction of nitration, when it reacts with the nitric acid, we need a temperature of say 50 to 55 degrees Celsius. So these are the reactions which a benzene undergoes. All of these reactions are electrophilic substitution reaction, and these two reactions, alkylation and acylation, as we have already discussed here earlier, are also called Friedel-Crafts reactions. Now let's study some of the questions from the past papers. Here is one of the question. It says compound H can be synthesized from benzene as shown. Now this is compound H. We can see that the benzene reacts in step 1 and it forms a product which has such a chain, carbon chain bonded to it. So you can see here that this is one of the carbon atom. This carbon atom is bonded to 3 other methyl groups, as we can see here in the diagram. So what we can understand here is that the main reagent that reacts with benzene is with one carbon atom, as we have seen here in the center, and then there are 3 methyl groups bonded to this carbon. So we can present it as 3 methyl groups, CH3 thrice. So the main reagent that reacts with the benzene is the chloro compound of this. So the question says state the reagents and conditions needed for step 1. So our reagent is the chloro compound of this and the catalyst aluminium chloride. The next question is again from one of the past paper. It shows bromobenzene can be prepared from benzene as shown. Name the mechanism of this reaction. Now, as we have already learned that all the mechanism of benzene are electrophilic substitution reaction. So the mechanism of benzene of this reaction is electrophilic substitution reaction. The next question says state the reagents needed for this reaction. Now as we are adding an halogen bromine, so our main reagent is Br2 and the catalyst is aluminium bromide or you can also use iron bromide. The next question says, draw the mechanism of this reaction, include all relevant curly arrows, any dipoles and charges. So let's start with the mechanism. Here with a benzene, we need an electrophile. Our electrophile here will be Br+. So when we draw a mechanism, a Br+ is shown to react with the benzene's ring. So we draw an arrow from ring to Br+. It forms an intermediate, as we have already learnt earlier in the mechanism, with a positive charged benzene. So if we are bonding bromine here with this carbon atom, the same carbon atom still have a hydrogen atom, and we draw a positively charged half ring this way. Now in this mechanism again we have to represent an curly arrow from the bond of hydrogen to inside of the benzene ring. And so final product will be bromobenzene. Here the hydrogen atom is removed. So we draw a bromine here with hydrogen ion replaced out. So there are many such questions you will find in the past paper. We have discussed only 2 of it here, but you will find a similar questions in most of the cases where all the reactions are electrophilic substitution reaction with a catalyst added to the reaction. The main part of the catalyst in all the reaction is to generate the electrophile, that is a positively charged species. In our next video, we'll be learning the further substitution reactions of benzene. Now that means a benzene is already substituted by one of the group and we'll be adding one more electrophile or few more electrophile to the benzene. So just wait and watch.